Hello, it is time to go over the 4-4 worksheet on angle, side, angle, and angle, angle, side congruence. This is kind of a follow-up to the previous section, but with two brand new congruence theorems for us to use. So starting with number 10, Stacy says there is not enough information to prove that these two triangles are congruent. Explain why she is incorrect. Well, if she has the information that's marked on the diagram, that means that she knows about the right angle, and it means that she knows about the angle up here, and also that CX is congruent to itself, which means we have angle, side, angle congruence. So there is enough. There is enough because CX is congruent to CX, so they're congruent by angle, side, angle. So they are congruent by angle, side, angle. Number 12, given the figure shown, write a two-column proof to prove that angle CAE, that would be this angle right here, is congruent to angle CEA. That'd be this angle right here. So we're showing that these two angles are congruent. So we'll make our T-chart. Add our statements. And our reasons. So number 1, we'll write down the information we want to use from what we've been given, which is those two angles which are congruent and the sides which are marked congruent. So I know that BC is congruent to CD. I know that angle CBA is congruent to angle CDE. And I know that angle CAB is congruent to angle CED. All of that was given. Then for 2, I can say, hey, those information pieces tell us that the two triangles on the sides are congruent by angle, angle, side. So we can say triangle ABC is congruent to triangle EDC, because I want to name them in the right order. EDC by side angle, side angle side. I'm like second guessing myself. It's not side angle side. That's why I'm second guessing myself. It's angle angle side. Sorry about that. Angle angle side. For number 3, once we know that these are congruent by angle, angle, side, we can state that CA and CE are congruent because corresponding parts of congruent triangles are congruent. So since these triangles are congruent, their base sides right here have to be congruent as well. So CA is congruent to CE by CPCTC. And once we know that those two sides are congruent, hey, this is an isosceles triangle. And in an isosceles triangle, I know that if the sides are congruent, the base angles are congruent. And that's what I set out to prove. So now, because of the information I know, I can state that angle CAE is congruent to angle CEA because of the isosceles triangle theorem. Triangle theorem. Sorry, my cat's automatic feeder just went off. All right, number 13. How might you decide what additional piece of information you need to prove that triangle JKL is congruent to triangle NOM? So we should probably decide what congruence theorem we want to use. Because if we wanted to use angle, side, angle, we would need different information. So for angle, side, angle, we would need to know that JK is congruent to NO, sorry. So to use angle, side, angle, we would need to know that JK is congruent to NO. But if we wanted to use angle, angle, side, we would need a different side length. There are two we could use. So for angle, angle, side, we would need to know either that KL is congruent to OM, or the other not included side, JL, is congruent to ON. And we don't need to know both of those pieces, just one or the other to use angle, angle, side. Up here, write a proof. We're given the information that's shown to us, and we want to prove that AX is congruent to CX. So this isn't too terribly difficult. We can go ahead and we can make our two columns. Is that straight across? I think so. All right, so we've got statements, reasons, and our given information is given to us. We have angle A congruent to angle C, and BX is congruent to DX. Those are given. But based on the diagram, we also know that there's a pair of vertical angles in here. We also know that angle CXB is congruent to angle AXD because they're vertical angles. So for number 2, angle CXB is congruent to angle AXD, and that's because of vertical angles. Now when I look at my triangles, I have 3 pieces of information. I have an angle, and a not included side. So those 2 triangles are congruent by angle, angle, side. So let's see, that would be triangle CXB is congruent to triangle AXD by angle, angle, side congruence. And now that I know the triangles are congruent by angle, angle, side, I can say that individual pieces of those triangles are congruent to each other because corresponding parts of congruent triangles are congruent. So I can go on to finish the proof and say, all right, my proof statement, AX, doesn't really matter what order you write it, AX is congruent to CX because of CPCTC. Just like that, corresponding parts of congruent triangles are congruent, and we are done there. Number 18 is triangle ABC, this one right here, congruent to triangle GHJ, wow, these are not triangles, these are quadrilaterals, I'm sorry. Quadrilateral ABCD and GHJK, are they congruent to each other? Well, look at the parts that they're made of. Triangle ABC is congruent to triangle GHJ by side, angle, side, right? This side and this side are going to be the same. So ABC, triangle ABC is congruent to triangle GHJ by side, angle, side. And the other 2 triangles, triangle ACD is congruent to triangle GJK by angle, angle, side, angle, angle, side. So triangle, gotta write this. Triangle, what are they called? ACD is congruent to triangle GJK by angle, angle, side. And technically that one should go first in my writing because I need to know that these two pieces are congruent to each other before I can show that ABC and GHJ are congruent by side angle side, but that's all right. So if we put them together, they're two congruent triangles, we put them together with their same corresponding sides touching each other, it means that the quadrilaterals that they create are congruent. So putting them together, so putting them together means that ABCD is congruent to GHJK by CPCTC. Just like that. Number 20, climbers want to determine a halfway point up a vertical cliff. If the top and bottom are parallel, Y is the point P where the ropes intersect halfway up the cliff. Well, first of all, there are a few different ways that we could do this. One way is that we could see that we have vertical angles, but I'm actually going to do it a different way because I think you might have done the vertical angles way. One thing to notice is that both of these are marked with a D, which means this length is the same. So I'm going to write that first. I'm going to say LM is congruent to NO. I know that for a fact. Okay? So I'm also going to say, wow, these two lines are parallel. And if these two lines are parallel, that creates some interesting relationships, like the fact that our alternate interior angles are congruent. So I can say that angle MLP is congruent to angle, let's see, MLP, ONP. ONP, and the other two pairs of angles, angle LMP and angle PON. So angle LMP is congruent to angle NOP. And both of those are true by the alternate interior angle theorem, since those lines are parallel, and these two lines will act as transversals to those parallel lines, so we've got alternate interior angles there. And now that I know that, take a look at my triangles. I have angle, side, angle, angle, side, angle, congruence. So now I know that the triangles, are congruent by angle, side, angle, which makes point P the midpoint of both those lines, right? If this is congruent to this, then P is the midpoint. If MP is congruent to OP, then P is the midpoint. So which makes P the midpoint of both lines. All right. Number 21. Keisha, Dwayne, and Lanzel are planning for a new bridge to replace the old bridge. The new bridge will start at point B, where Dwayne is standing. So let's see. We'll start at point B, where Dwayne is standing, and end at point C, where Keisha is standing, right here. Lanzel walks to point D, then walks parallel to the river until he reaches point E. So he does this, where he sees Dwayne and Keisha are aligned. There's Dwayne, there's Keisha. What is the distance from E to B, why is the distance from E to B the length of the new bridge? So we just have to figure out why these two triangles are congruent. So I know some things about this. I see some vertical angles here, one right here, and one right here. So I can start with that. I can say angle ABC is congruent to angle EBD by vertical angles. Angle EBD by vertical angles. All right. Another thing that I can show is I can show that these two lines are parallel because it said Lanzel walks parallel to the river. So these parallel symbols are there, which means the dotted line is a transversal, which further means that this angle and this angle are alternate interior angles, which means they have to be congruent. So angle ACB is congruent to angle EBD by alternate interior angles. Right? I also know, because it's given to me, that AB is congruent to BD. They're both 30. So AB is congruent to BD is given. So those are three congruencies I have, and if I look at those three congruencies, that gives me angle, angle, side congruence, right? It's not angle, side, angle, because these two angles don't have an included side. It's angle, angle, side. So I can say the two triangles, triangle ABC is congruent to triangle ABC, DBE by angle, angle, side congruence. And since I know those triangles are congruent, now I can answer the question about the lengths of the new bridge and where Lanzel is standing. Those are going to be the same by CPCTC. So CB is congruent to EB by CPCTC. And there are all your steps of reasoning, which means you are correct. Number 23, complete and copy the table to identify the congruent pairs. So this is telling us about corresponding parts of congruent triangles. So if we have, for example, angle ZXY, that's right here. Its corresponding angle is angle ZXW, right? No, ZXY has no marker on it, ZXY. So XZW, that's going to be the one that corresponds. So that'd be angle XZW. The next one is angle WXZ. So WXZ is right here with 2 marks. And then XZY is going to be the corresponding one. That's got 2 marks. Angle XZY. Then we've got side XZ. Side XZ is in the middle. It's congruent to itself because of the reflexive property. So that would be side XZ or ZX. It doesn't matter. And finally, WZ. WZ is the side with 1 arc and no arcs. So XY is the side with 1 arc and no arc. So it's congruent to XY. And there you go. And finally, given these two triangles, what is the value of x? And if these two triangles are congruent, we can say, oh, hey, that means that 2x minus 15 is going to be corresponding. We've got to figure out which one S is corresponding to. So S is the last letter. N is the last letter. Here's N. So we need to figure out what N is first. We're going to do 180 minus 50 minus 55. This is going to equal 75. So N is 75. And so if N is 75, it's corresponding to S. So that's 75 equals 2x minus 15. Add 15 to each side. 90 equals 2x. Divide both sides by 2. 45 is x units. So 45 is the answer. There you go. If you've got any questions on this worksheet, please let me know. and have a wonderful day.